Good morning to one and all. Today I am going to talk about carbon neutrality approaches for IoT enabled applications. This particular work is mostly focusing on neutralizing carbon emissions that affect the society. Towards this end, in this talk, I will be covering the introductory part, the contribution that is made, mostly focusing about a few approaches that are done and some of the research directions before I conclude the talk. In fact, the carbon neutral emissions are very impactful, which changes the global climate. The heat that rises in Earth is tremendously increasing, and it is expected that it is creating a big hazard in the near future. That's the reason IPCC reports and many organizations have come forward to address this challenge, to address this problem. We reached at least 2,150 gallons, gigatons already in the year 2011. Our Earth is supposed to accommodate only 2,900 gigatons, and it's continually increasing every year at the pace of like 50 billion tons. So there should be a 360-degree ways of targeting this problem. One such problem could be to reduce the utility of applications or diligently solving the application, especially in the field of IoT cloud domain. The reason is IoT applications are very often it's tremendously used in the sense, right? It is obviously an important problem in situations like sensor applications where you try to always use the application, always use the resources and heat up the computing power, which indirectly create heat, and by this they use air cooling systems, and because of this it indirectly create the carbon emissions to the globe. In short, IoT is a sensor technology. And what is the sensor technology? It is basically a future internet, which means many things are getting connected. Lot of objects are getting connected. It is a kind of an extension of internet. So when many billions of devices are getting connected for an application, it has to be very carefully solved or very carefully controlled. Otherwise, the carbon emissions, the contribution that it makes, that such applications make to the society will be tremendous. So we have to control them. You can observe that in an IoT system, you will see that a lot of sensors, actuators are connected through a gateway to cloud or edge fog cloud architectures. As like you could see here, the devices are connected with the help of some microcontrollers maybe, or Raspberry Pi kind of microprocessor based devices, and then they are communicating to the cloud services. And this is like a long running application because most of these applications take long time to run, right? Say for example, you want to assess the health condition of a patient. It is a non-stopping application, especially in a periodic monitoring system. A healthcare system with IoT enabled sensors will always get connected, always it has to be powered on, and this will obviously create a lot of carbon emissions throughout the year. This has to be controlled. That's the reason what we say in IoT enabled applications, we need to control such carbon emissions. So what kind of approaches are currently followed in the system? Either you provide a better sensing or monitoring mechanism or sensor enabled ecosystem. For example, you could provide a better communication protocol, instead of utilizing like Wi-Fi or very expensive communication protocol, in some applications, if you are allowed to do LoRa kind of technology or Zigbee based protocol, then it is better to choose such kind of communication protocols. Or you may need to use the sensors or sensor enabled systems such that most of the time it has to be in a sleep mode, and only when they need to be enacted or powered on for sensing purposes, then you could use them. So a better sensing capability or sensing procedure should be followed. By this way, you could contribute, you could minimize the energy consumption, and obviously you provide less carbon emissions to the society. Or you create kind of modeling or prediction systems that would forecast what would be the energy consumption and what would be the carbon emission because of executing such kind of applications. Or you may need to create some kind of simulators or optimization kind of tools that can simulate and assess what would be the energy consumption, what would be the carbon emission from this particular IoT enabled application. Say in a healthcare application, when it has to be monitored continually, what would be the energy consumption, what would be the carbon emission. These kind of things could be assessed by simulators or optimization tools. Or you could create some kind of architectures, hierarchical structures, or carbon emission controlled management architecture, which also involves a lot of renewable energy sources to power on the IoT applications. Or you could create some kind of policies like providing tax, too much tax for carbon emission systems, or providing some kind of blockchain based solutions to protect or prevent the data that if someone committed this, carbon emissions, they have to be penalized. These kind of solutions could be followed. Or you could create energy efficient mechanisms in applications so that you could control the carbon emissions. Or you could create some kind of real applications that is only focusing on carbon emissions. Like for example, monitoring the carbon emissions in school, monitoring the lighting systems in house, or write an application that could create a better building system which prevent carbon emissions. So these kind of methods are already practiced by a lot of researchers in the literatures. This particular article is mostly focusing on what kind of methods are followed, what kind of approaches are followed by researchers in the past to target these carbon emissions. So this particular table comes out of the basic, after going through a lot of articles, and basically it was searched with the title carbon as well as IoT, because the focus was more towards IoT based systems and how IoT based systems can contribute to carbon emission and how it can be targeted. So with that intention, this particular article was written after a lot of survey. And as you could see from the literatures, we could observe that several researchers have focused on different sectors like energy, smart cities, smart home, power grid, smart IoT, that means industrial IoT sector, or power grid sector, and so on. And they tried to minimize carbon emissions with the help of including some communication protocols, better communication protocols. And out of most of the communication protocols that we could observe, we can see that they are mostly focusing on LoRa based technology, which is long range wide area network. This particular protocol has a capability of withstanding long distances And if you see the learning algorithms and or learning models that were implemented for especially for learning purposes in IoT applications, we could see like federated learning is most often targeted, including like federated deep learning concepts. So the idea is distributed learning. The distributed learning to create models. So we could see like not many normal machine learning algorithms were implemented for targeting carbon emissions. The work is spread across the learning algorithm. The learning part is spread across a lot of small compute units, so that the large number of IoT systems that may be connected or controlled by spreading the work, and by this you minimize or neutralize the carbon emissions. Yeah, you could also observe like some are more towards harvesting, some target the efficiency aspects in the cloud. Most importantly, like optimization and the energy harvesting methods were practiced in the past. While we specifically targeted the architectures, IoT-enabled systems that target carbon emissions, we also, it could be understood from the literatures that some control measures policies were followed in the past. Most importantly, ISO controlled policies. ISO standard has provided some policies to prevent carbon emissions. Some researchers have particularly implemented the blockchain approach to prevent the delta that comes out of carbon emissions, because an IoT application, when it is executed on some compute nodes, if these compute nodes are contributing some percentage of carbon emissions to the globe, the data can become unnoticed. So it can be protected or prevented in the blockchains, so that if someone tries to change the data, right, tries to change this kind of information, could be prevented, because blockchain in nature it has this data immutability feature. The next policy which some of the researchers have adopted in their literatures are tax capping, right? So they fixed some kind of capping to carbon emissions. So beyond that, you are not allowed to emit carbon. So the taxing is fixed and for each and every application, and if it is beyond that, then the penalty will be very, very high, and it is it can even create a lot of punishments to the defaulters. Payback is one method that is followed in the part of policies. Basically, here the amount of carbon emissions are contributed in another way, such that they have to either plant trees or compensate to the society by constructing some very expensive countermeasures or countering mechanisms, including some purifiers which they can provide in the environment. So that will be a little bit expensive, but that's also kept as policy, because you are paying back to the society by neutralizing the carbon emissions. Or providing reforestation. One of the researchers has have put forth an idea of reforestation, and we could also observe that from literatures, still this carbon emission as well as carbon neutralizing mechanisms are not very well implemented or practiced in the literatures. So this becomes an important portfolio where the researchers could take the topic forward for bringing forward this carbon emission neutralizing mechanisms. So basically there are so many approaches to neutralize carbon emissions, and what I come forward to express here is IoT enabled applications are really contributing more energy consumptions, which indirectly create carbon emissions. And as IoT enabled application developer, we have to be very, very careful to control this kind of carbon emissions. And that's why the approaches that are already practiced to neutralize carbon emissions to the society were surveyed, and all the different approaches were highlighted, and also the policies that are followed to neutralize carbon emissions, which can be linked with some of the applications that an application developer could develop in IoT domain could be were discussed. So with this, I thank the conference authorities for giving me this opportunity, and I am most welcome to the questions. These are some of the references. Thank you.